Hello everyone. In this session, we will see about simplification of grammars. This simplification of grammars is one of the basic steps that we have to follow when you are dealing with or converting a grammar into the normal forms. So we will see how you can convert grammar to normal forms, one among either Chomsky normal form or Grayback normal form. In short, we call it as CNF and JNF. Okay. So for both of these normal forms, the grammar should be in a simplified way. Simplified way I mean, yes, simplified way means transforming the grammar into another form such that there are no unnecessary productions and simples in it. Simples here we mean non-terminals. Okay, so therefore both these original grammar and the transformed grammar should accept the same set of languages. So the meaning of the grammar should not be changed when you are doing this transformation. There are some steps to be followed, and these steps should be followed in the order they are given. Okay, first one is you have to do the elimination process of epsilon productions, followed by unit productions elimination, followed by useless symbols elimination. If this order is changed, then you might result in a different grammar which will accept a different set of language other than the original grammar given. And also in this elimination of useless symbols, first you have to check for non-generating symbols followed by non-reachable symbols. Even if this order is interchanged, that is elimination of non-reachable first followed by elimination of non-generating, then also the certain grammar will be a different one. So therefore the steps to be followed are, first you have to identify the epsilon productions and eliminate them. Next you have to identify the unit productions and eliminate them, followed by elimination of useless symbols. In case of elimination of epsilon and unit productions, you do some substitutions only. You don't remove it as such. You do some substitutions. Whereas in case of elimination of useless symbols, you entirely remove the productions. So we will deal each of them one by one. So first one is elimination of epsilon productions. So epsilon productions, first we have to understand what are these epsilon productions. Epsilon productions mean any grammar production of the form a non-terminal can generate an epsilon through one or more steps. We call it as epsilon production. Yes, for simplicity, A determines epsilon is a direct epsilon production. Suppose if we have A determines B and B determines epsilon, which means A determines B, B determines epsilon, and therefore A determines epsilon. So therefore, in this case, both A and B, both are epsilon productions. Okay. So epsilon productions are nothing but they are of the form a non-terminal determines epsilon through one or more steps. So here we call these symbols as nullable symbols. That is, those non-terminals or variables which can yield epsilon are called as nullable symbols. Okay, so first thing is you have to identify the nullable symbols, and after identifying the nullable symbols, you have to write the different versions of the production body with and without the nullable symbol. That is, you can see this example. Okay, so okay, so these are the different grammars. Single grammar with different productions given. A determines B, A determines C, A determines epsilon. C determines A, C determines epsilon. D determines AC, B determines CAD. Yes, the question is to identify the nullable symbols and eliminate the epsilon production. Even if the question is just eliminate the epsilon production, you have to first identify what are the nullable symbols. Okay, so here by when you see the grammar A determines epsilon, C determines epsilon, we should not conclude that A and C alone are nullable. Okay, this A and C directly derives epsilon, but if we substitute this A somewhere else, we have to check whether you get epsilon. For example, so we know now A and C are nullable. So in the set nullable, I can place A and C. Okay. How this B has come? Yes, B determines CAD. We know that A and C are nullable. What about D? D determines AC. So if I substitute instead of A epsilon and instead of C also if I substitute epsilon, then I will get D determines epsilon. So through substitutions also I am getting this epsilon. So therefore D is also nullable. So when I substitute, we know A and C are nullable directly. Now D is also nullable using this production rule. Therefore B is also nullable. So we can say that A, B, C and D, all these are nullable. Now after elimination, the resultant grammar will be like this. You should have the original grammar. So A determines B will be there, A determines C, and you will not have epsilon part. Epsilon is removed. So C determines A, epsilon is removed. D determines AC. This is the original grammar, and as we mentioned in the previous slide, different versions of the production body should be present. So AC is as given in the grammar. This A I have obtained by substituting in AC instead of C epsilon. Instead of C, if I place epsilon, the resulting will be 1dA. And also A is nullable. So instead of A, if I put epsilon, the resultant production is C. So we have to write the different versions of it. Okay. And the last production, B determines CAD. So you will write this original production as it is, CAD, and then followed by, instead of D, since D is nullable, if I substitute epsilon, I'll get CA. Instead of A, as it is nullable, if I substitute epsilon, I'll get the remaining CD. So CD is placed here. Instead of C, since it is nullable, if I place epsilon, it is AD. Okay, so we have now chosen each one variable each and placed epsilon, and the resultant are these three productions. What if substitute more than, that is 2 epsilon, since A and D are nullable, if we substitute epsilon for both of these, I'll get C. Yes, if I substitute epsilon for C and D, I'll get A. If I substitute epsilon for C and A, I'll get D. Okay, so we have to write the original production and also the different versions of it. This is how you can eliminate the epsilon productions. So you have to identify the nullable symbols by directly and also by through many steps. And after that, nullable symbols, for the nullable symbols you substitute epsilon and write the various combinations on the RHS. Next step is elimination of unit productions. So what is a unit production? As the name implies, unit means one. Yes, so in a context-free grammar, the LHS will always be of length 1. What about the right hand side? Right hand side can be of any form. It can be combination of variables. It can be combination of terminals. It can be combination of terminals as well as variables. Okay. Suppose if we have a grammar protection of the form, a non-terminal can be a single non-terminal, then we say it is a unit protection. Okay. So this unit protection, if we have a unit protection of the form A can be B, you will have something like B can be some other things to substitute. So this will take more time for processing, and therefore it is a best practice to have this substituted, or this for B you have some protections, right? That protections can be directly given for A. Okay, so this is the concept behind elimination of unit protections. So to identify this, you will require to check what are the unit pairs. Okay, so a pair A comma B is called a unit pair if A determines B. Okay, so through one or more steps, you'll have a star here. Yes. Okay, through one or more steps, if you are able to determine a single unit protection, then we say it is a unit pair. If after identifying unit pairs, you have to substitute all these non-unit productions of the variable of RHS to it. So you can, next example, you are given the grammar with all these productions. Here the non-terminals are E, T, F and I, and the terminals are plus, star, open parenthesis, close parenthesis, A, lowercase a and lowercase b. The unit pairs here will be E, T is one pair, T, F is another pair, F and I is another pair. You cannot have a unit pair as a combination of non-terminals and terminals. Both of them should be a non-terminal, or both of them should be a variable. So we have these three pairs. Okay. Now instead of T, I have to substitute all the productions of T. So when I try to substitute all the productions of T here, again here T has a unit production. So therefore, to find the productions of T, I have to substitute the production of F. So here again I have a unit production. So again I substitute for I. So here what I get is I determines A, R or B. So this A or B should be substituted to F here. So I'll get A or B or E. Now this F should be substituted to this T place, F place. T determines F, so F has all these. And here E determines T. I'll write all the productions of T in place of T over here in the RHS. So like this, I substitute the unit pairs and arrive at this production. Even though the number of productions in this grammar is more, for processing it will take only minimal time, because during process the substitution process is eliminated as we have done a direct substitution here. So this comes under elimination of unit productions. Next is the elimination of useless symbols. So what are these useless symbols? Useless symbols are those productions which does not contribute anything to the grammar productions given. Okay, so we have to identify those productions which do not yield any terminals, and those symbols which are not reachable from the starting symbol. So such productions it will never be used even though it is in the grammar. Okay, though the meaning of the grammar will not be changed, there is no use of those productions or symbols in the grammar. So it is best to eliminate those productions or symbols, and that way you will have a minimized production rules in your grammar. Okay, so to eliminate these useless symbols, you have to follow the two steps. One is identification of non-generating symbols first, followed by identification of non-reachable. This order should not be changed. Okay, so this has to come at first. This should be the next. You can see this example. S determines AB or A determines A. So useless symbols, first you have to identify the non-generating. S is generating. Yeah, S generating means those non-terminals that yield collection of terminals alone. So A determines AB. S determines AB. S determines A. A is a terminal. So S is generating. What about A? A determines small a. It is a terminal. A is also generating. You don't have any rules for B. Yes. So therefore B is not generating. Even if you have a grammar like, if you have like B determines, say, you have again saying BA. If we have this production rule in this grammar, is B generating? B is not generating here. Why? Because how many times you substitute for B, this uppercase B, that is non-terminal B, will be repeating again and again. For this A, I can substitute small a, it's a terminal. But for this B, I cannot substitute a terminal because B doesn't have any rule which has a terminal alone in it. So therefore, even if we have a production like this, we can say B is non-generating. Okay, so in this case, you have to eliminate the production as such. This AB, since B is non-generating, should be removed as such. So you have only S can be small a and A can be E. Now from the resultant grammar, I have to check whether all of them are reachable. All the symbols are reachable. So I have S can be A. From S, I cannot reach any other non-terminal. Yes. When you see, look into this production, from S, A is reachable, from S, B is reachable. So all the variables are reachable from the starting symbol. But after elimination of the non-generating symbol, the uppercase A non-terminal is not reachable. So therefore, A is non-reachable and we can eliminate this as such. So you'll have only the production S can be. What if you do this in the reverse order? If you have from this, if you find non-reachable first, you will arrive at there are no non-reachable symbols. And then you will arrive at non-generating is B and will have these two productions all together. But you will never use this A at all. So all these are the steps you have to follow prior to doing a normal form. Either it can be a Chomsky normal form or Gribak normal form. So to repeat, thank you. And so in the next session, we will see the actual conversion of Chomsky normal form followed by the conversion to Gribak normal form.